Hello everyone. We are discussing wave optics, and so far we have seen how this equation works. Now, all the information which we gathered from this equation, we'll use that in interference. Right on the heading interference. This S1 is a source of light, and the distance of x from it at point P. Light waves are being received. Behind S1 is S2, and S2 is also sending light waves towards the same point P. This S2 is this much behind S1. Delta X shown in blue. This delta X, I hope you remember from 11th, is called path difference. Waves coming from S1 and waves coming from S2, they have a path difference of delta X, which means if S1, waves coming from S1 are traveling a distance of X, then waves coming from S2, they are traveling a distance of X plus delta X. But the important thing is, both S1 and S2 are of same frequency. Interference means superposition of two simple harmonic motions. And maybe you remember this from 11th. When you superimpose two simple harmonic motions of same frequency, then only resultant motion is simple harmonic. So both S1 and S2, they are of same frequency. We'll write these points later on. So they are of same frequency. We can say this, that light waves coming from S1 are producing an electric field at this point, which is at a distance of x at time t, as E naught sine omega t minus kx. Now, just for simplicity, I will replace this E naught with capital A. You know that in SHM we normally represent amplitude with what? A, amplitude, capital A. So remember what this A is. This A is basically E naught. And what is E naught? Maximum of electric field. produced by this wave. Maximum of electric field produced by S1 at any point is capital A. If we go for equation of light wave, which is coming from same source as 2, second source as 2, then its equation is sine omega t minus k x plus delta x. What is B? Maximum electric field produced by second source. What is E2? Instantaneous value of electric field, that is electric field at time t at a distance of x plus delta x from the second source. What is B? Maximum electric field which it can produce. This is E1, this is E2. This is omega, this is omega, this is k, this is k. These things will remain same because I told you that S1 and S2 are of same frequency. If they are of same frequency, then they will also have what? Same wavelength. For both sources, speed of light is same. Omega is 2 pi f frequency. K is 2 pi upon lambda, or omega upon c, where c is speed of light. Speed of light is same for S1 and S2, omega is same for S1 and S2, and therefore we are using same omega and k for S1 as well as for S2. The only change is in this value of distance of point P from the source. Now, this E2 can be written as B sine omega t minus kx minus k delta x. Now what is phase of E1? Omega t minus kx. And what is phase of E2? Omega t minus kx minus k delta x. So this part is basically what? Phase difference between E1 and E2. And how do you define phase difference? For phase difference, we write delta phi. And delta phi is coming k times delta x. Negative sign is simply telling you that E2 is behind this much. We are interested in the mod part, which is k delta x. So this is phase difference delta phi, which is related to path difference using this formula. Delta phi is now what? K. What is K? There. 2 pi upon lambda into delta x, or a better way of remembering this is delta phi divided by 2 pi is delta x divided by lambda. Delta phi upon complete phase during one oscillation, 2 pi. Path difference divided by complete length of a wave, which is lambda. This is relationship between phase difference and path difference, which will be used in discussing interference. Note down this much, and if you find that things are a bit mathematical, yes, they are, but slowly you will understand each and everything, provided you pay great attention to all this thing. Note down this much. Now, when these two waves arrive at P, total electric field is given by E1 plus E2. Electric field. These are two vectors. Suppose at point P, electric field due to first is E1, due to second is E2. Add these two and you will get what? E total. Fields can be like this or they can be like this, in the same direction or in the opposite direction. Their magnitudes will also be different, and that will be decided by this number K delta X, which is called phase difference. So what is E total? After you superimpose electric fields, total electric field. After you superimpose means when these two waves interfere with each other. Now, in this E total part, we are interested in the amplitude of resultant wave. Now, I have used A and B so that you can remember something like this. This E total will be total amplitude sine omega t minus kx plus some alpha. Omega t minus kx plus some alpha. What is alpha? Again, additional phase which superimposed wave will have. E1 is omega t minus kx. As compared to E1, E2 has an additional phase of k delta x, or you can say it's behind k delta x. When you superimpose these two, the resultant wave which you get has some other alpha. This can be positive, this can be negative. We are not interested in the alpha part because you know that variation because of sign is so fast that our eyes cannot see that fast variation. Instead, our eyes go for intensity, which is average power, and that intensity is proportional to amplitude square, amplitude square, amplitude square. Just because of that, instead of opening this and presenting every part in terms of sine and cos and then simplifying that, we can directly say whole thing is in this form. And when things are in this form, maybe you remember A total. This A total is A square plus B square plus 2AB cos of delta phi. So when we superimpose these two waves, amplitude of the resultant wave will be A square plus B square plus 2AB cos delta phi. You have seen this thing in vector addition as well as in alternating current. In 11th, during oscillations and in waves also. So this is your total amplitude. Total amplitude means what in this case? Maximum electric field at point P due to the superimposed wave. Note down this and then we'll write a few points. Note down this much. Right on this point, A is maximum electric field due to S1. B is maximum electric field due to S2. And A total is maximum electric field due to superposition of E1 and E2. Now, frequency of first wave omega, second wave omega, resultant wave omega. When two SHMs of same frequency are superimposed, resultant motion is also simple harmonic motion and has same frequency. You can see your notes from simple harmonic motion and you will find these things. We are interested in this A total part, and this will explain everything about interference. Let's handle A total now. Case 1. If delta phi is 0. If delta phi is 0, then cos 0 is what? 1. If cos 0 is 1, then this is what? A square plus b square plus 2ab. That gives us A total as what? A plus b. A plus b whole square under the root will give you what? A plus b. Which means what? If phase difference between the waves is 0, then amplitude of the resultant wave is simply A plus B. This is A plus B. That means you are directly adding their individual amplitudes, individual maximum electric fields, which in physics is called constructive interference. Constructive interference. This A plus B part. Now what is A plus B? We'll try to visualize this also. But before that, let's find out delta x. What is delta x? Delta x is delta phi divided by 2 pi multiplied by lambda. So if delta phi is 0, then delta x is also what? 0. When phase difference is 0, this equation is telling you that path difference is also what? 0. But now, you also know that delta phi, if it is 0, it will be cos 0 and will give you 1. But if after delta phi I go for 2 pi, which is 360, or I go for 4 pi, 6 pi and so on. In short, I can say 2 and pi. Look here. If this is 2 pi, 2 pi upon 2 pi cancel and you get what? Lambda. 4 pi, 2 lambda. 6 pi, 3 lambda. 2 and pi will give you what? N lambda. If path difference between S1 and S2 is n lambda, where n starts from 0, 1, 2, then at point P, constructive interference will take place. Constructive means since you have amplified total amplitude, intensity of light will become what? Maximum. And when intensity of light is maximum, you're going to see that you have a very bright spot on the screen. On the screen means at point P where this interference takes place. This is called constructive interference, and that spot will be called bright fringe. Put down this case 1 and then we'll go for case 2 also. Put down this much first. Now, let's first understand meaning of this 0, 1, 2, lambda, 2 lambda, n lambda. They are above a simple figure. And for this figure, you need to understand everything we did in the previous class. Just remember these values. This is the position of S1. This is your point P. And this is your wave coming from S1. For constructive interference, what we do is something like this. This is the position of S2. Now remember, S2 is just behind S1, but just so that you can see it clearly, we're drawing the whole thing in this form. This is a wave coming from S2, arriving at the same point P. S2 is over here. This is your point P. What does it mean? It means this. If let's understand with the help of oscillations, and remember these are for us in this chapter electric fields. So these are two balls and the balls are oscillating like this. This is called same phase. When the black marker goes up, blue one also does the same. They both arrive at their negative amplitude simultaneously. They both pass through their mean positions simultaneously. This is called zero phase difference. Now, whatever happens at S1 does happen at P also. Distance between this and this is what? Lambda. What is lambda? Wavelength. What is the meaning of wavelength? Wavelength means separation between 2 points which oscillate exactly same. Like this. If you have a particle at S1, another particle at P, then their behavior will be like this. Whereas if you have a particle at the position of S1 and the other one right here, then their oscillation will be in this form. This is called a phase difference of 180. But whatever happens at S1, now you know that is going to happen at P. Whatever happens at S1, exactly same type of thing is happening at S2, and therefore same thing will happen at P, which means if electric field at P at some time due to S1 is 3, it will be up. Due to S2, it will be 4. They have different amplitudes. Because of S1 is 3, because of S2 it is 4, then how much you got? 3 plus 4, 7. Now suppose due to S1 at P electric field becomes A becomes maximum. At the same time, electric field at P due to S2 will also become maximum. So if this one is A, this one is B, together they will produce what? A plus B, which is called constructive interference. And now you can see that what is path difference between S1 and S2? For this position, your delta x is what? 0. Your delta phi is also what? 0. Between S1 and S2, there is no path difference, there is no phase difference. Now look carefully. If instead of placing S2 at this position, we choose this position, I hope you all can see this additional thing in red. If I choose this new position S2 shown in red, then what happens? Whatever electric field is present over here will also be there at this position. Will also be there at this position. Distance is lambda. 2 points separated by lambda, they behave exactly in the same manner. It's not about this. Look at the peak. Look at the peak. Separation between the peaks is also what? Lambda. Choose any 2 points separated by a distance of lambda and they will behave exactly same. So if electric field at S2 is 4 at some point at a particular time instant, you found that electric field at S2 is 4, then at this position it will be again 4, at this position again it will be 4. And the important thing is phase wise at P, both waves coming from S1 and S2 are doing same. Doing same means again it will be an oscillation of this type. But since we have placed S2 lambda behind as compared to this position of S1, this is lambda behind, we say that now we have a path difference of lambda and corresponding phase difference. Phase difference means something like this. Suppose phase at this point is 0 degree, then phase at this point is 360 or 2 pi. This is 0, this is 0. If this is 0 degree, this will be 360. This will be 720 or what? 4 pi. Which means what? At P, due to S1 and S2, what is the phase difference? This is 4 pi, this is 2 pi. Subtract, you get what? 2 pi. So the phase difference is what? 2 pi. From now onwards, you don't have to write like 0, 360, 720. Just do what? Look at this additional change. The whole portion it represents and gives you what? 2 pi. That's what it is. 2 pi. When you place S2 lambda behind, it creates a phase difference of 2 pi. A phase difference of 2 pi means angle between these two markers is 0, 90, 180, 270, 360. But they are equivalent to what? 0 only. So when you have a phase difference of 0 or 2 pi or 4 pi or 2 and pi, oscillations are of this type. And therefore, whenever at P electric field is maximum, at that very instant electric field at P due to S2 will also be maximum, giving us a total electric field of A plus B, which is called constructive interference. Do you understand this graphical part? Yes or no? Mention in the comment box. Good. Note down this graph. This next thing, this next graph will help you a lot. These are, I hope you remember from the last class, these are E versus X graphs. E versus X. You can see different positions and therefore E versus X. At a given time, what you are looking at, electric field at S1 is 0. At a distance of lambda by 4, it is maximum. At a distance of lambda by 2, it is 0, and so on. Now, if I ask you to plot E versus T graphs, then from the previous lecture, I hope you remember this much. This is E1 versus T. And if E versus X is of this type, then E1 versus T will be of this type. This is something we have already discussed in previous lecture. If you go for E2 versus T, don't forget to draw these partitions. If you draw like this, then you will have a proper alignment. We'll be plotting E total. Your E2 will look like this. This amplitude this is A. Maximum electric field due to source 1. This is B. Maximum electric field due to second source. When these two superimpose, what do you get? You get something like this. Immediately, this height is now A plus B. A plus B is for this point, and the arrow is for the vertical axis, E total. All the graphs are of same frequency, that means same color, but their amplitudes are different and therefore they are showing different intensities. This one is A plus B maximum, and therefore you see maximum brightness. In this graph, we have plotted E versus X at different points, variation in the strength and direction of electric field. This is something which you are looking at point P. So at point P, I asked you to draw a graph of E versus T. This graph is plotted at a given position. These graphs are plotted at a given time, at a given position, at different times. What is happening? This is not lambda by 2, this is capital T by 2. Write down capital T, capital T, capital T. Height is A, height is B, And the overall height after superimposition is what? A plus B. Show this A plus B on the left side. Draw this part. Let's see how many of you will answer this. If intensity due to source 1 is I1 and intensity due to source 2 is I2, then what is I total in this particular situation? For constructive interference, if intensity due to source 1 is I1 and due to source 2 it is I2, then what is total intensity of resultant wave? Source 1, its intensity is I1. Source 2, its intensity is I2. I'm looking for I total. Let's see who can answer this. And the answer is I1 plus I2. Which some of you have also answered. But this is not correct. We don't find intensity like this that you simply add I1 and I2. Why? Look here. What was A total square? A square plus B square plus 2AB cos of delta phi. Shifted the root, made the square and all. We know that intensity is proportional to amplitude square, which means this A total, you can replace it with I total. A square with I1 v square with I2, a with root I1 and b with root I2. This is amplitude and therefore it will be square root of intensity. Cos phi, keep it outside. This is the general formula. For constructive interference, I total will be I1 plus I2 plus 2 times root over I1 I2. So it's not I1 plus I2, it is I1 plus I2 plus 2 times root over I1 plus I2, I1 into I2, which is nothing but root I1 plus root I2 whole square. So remember, for finding total intensity, you just do not add individual intensities, because we are using this formula which tells us that intensities will be arranged, should be arranged in this form. Or you could have used a direct shortcut. What is that shortcut? Look here. We know that A total is A plus B during constructive interference. Remember, shortcut is for the constructive interference. But what is A total? A total is root over I total. There will be a proportionality constant, but that will be cancelled because it's present in this term, as well as in this term, and therefore I'm directly using root I total. What is A? Root I1. What is B? Root I2. Now what some of you did, you replaced A with I1, B with I2, A total with I total, and therefore you produce this answer. But what is happening? A total is this, A root I1, B root I2. That means I total is, shift the root there and you get root I1 plus root I2 whole square. Wrote down this as well as this, and don't forget to mention this and across like this. Now let's talk about destructive interference, and remember all these formulas. Well, I had sent a lecture yesterday. Those of you who have seen that lecture on optics, write down yours in the comment box. If you have seen the complete lecture, then write down yours in the comment box. Write down case 2, which is destructive interference. Destructive interference. If delta phi, instead of being 0, 2 pi, 4 pi, if it is pi, 180, 3 pi, 5 pi, 2n minus 1 pi, where n is again 1, 2, 3, 4. If n is 1, 2 minus 1. If n is 2, 2 into 2, 4 minus 1, 3, and so on. For these values of phi, cos will be minus 1. And if cos is minus 1, then your A total will take this shape. A square plus B square minus 2AB. Cos delta phi minus 1, which is A minus B. In fact, whichever is the larger one, from that subtract the smaller one. If this is 10, this is 8, 10 minus 8. If this is 8, this is 10, then make this 10 and this 8 and subtract. You're getting the amplitude part. Everything else is what? Those very fast oscillations, roughly 10 to the power 15 oscillations in 1 second. Something we discussed in the first lecture. So this is your A total, which is coming A square plus B square minus 2AB, A minus B. Let's also write the intensity part, I total, which will be I1 plus I2 minus 2 root I1 I2, or simply root I1 minus root I2 whole square. We'll understand this graphically also, but that's how you will find your A total, and this is your I total. Suppose A and B are same, 10 and 10. Suppose 10 minus 10 will become what? 0. What is A total? Maximum electric field due to superimposed wave. If that becomes 0, which means what? There is no electric field left. If no electric field is left, then at point P, you will find a completely dark spot, which is called dark fringe. In the process, the phenomenon is called what? Destructive interference. It takes place when both waves interfere with each other. Waves coming from S1 and S2 interfere with each other while oscillating in opposite phases. What is meaning opposite phases? We'll understand that again with the help of those graphs. Note down this, and also the value of delta x. If this is delta phi, what will be delta x? Delta x will be delta phi upon 2 pi into lambda, that is 2n minus 1 pi upon 2 pi, you get lambda by 2. 3 pi, you get 3 lambda by 2. It's very easy. This much phase wise is what? Pi. Length wise is what? Lambda by 2. Remember this. So pi is lambda by 2. 3 pi, 3 lambda by 2. 5 pi, 5 lambda by 2. And finally, 2n minus 1 lambda by 2. So this is the formula for path difference during destructive interference. Note down this. Now, look at this graphical part. Remember the values of delta phi and delta x. Look here. This is S1. That's how wave reaches point P. And remember, we are drawing E versus X graphs. This is the position of S2. And that's the behavior which you see at point P. What is this? S1 and P. It's this. Same phase. But what about S2 and P? It's like this. They are in opposite phase because of this additional phase difference of pi. Right at this place, delta x, everybody can see is what? Lambda by 2. It's lambda by 2 behind. Phase difference wise, it is what? Pi. How do you arrive at this pi? This is 0, phase, pi, 2 pi, phase wise, and therefore I'm showing the whole thing in blue. Blue means we are mentioning phases at these points. This is 0, let's call this also 0. They are exactly the same profiles. This is 0, this is pi, this is 2 pi, and this is 3 pi. So what is phase difference at point P? 3 pi minus 2 pi, pi. And again, you don't have to do this again and again. Simply look at this part. This much lengthwise, phase-wise. What spatial happens at P now? Look at these two shapes. So something like this is happening. They are oscillating in opposite phases. When amplitude of this is A, its amplitude is B but in the negative direction. So if electric field is 10 up, 8 down, what will be the total? 10 minus 8, that is 2. Which means you are reducing the amplitude of electric field, you are reducing the intensity, and therefore it is becoming darker, which is called destructive interference. Now next, you place your S2 at some place like this. So at this place S2, what is the phase difference, path difference starting from this S1 position? Lambda by 2. Let's count it like this. 1 lambda by 2, 2 lambda by 2, 3 lambda by 2. Delta x is 3 lambda by 2. Phase wise, pi, 2 pi, 3 pi. You have your S2 at this position or at this position. By the time wave arrives at P, due to S1 and S2, you're getting opposite phases and therefore you'll be subtracting their electric fields. Look, if we draw E1 versus T, E2 versus T, and E total. Then how do you draw the graph? It starts from this. If you plot your graph, if it starts from this, then that's how you'll be plotting your E versus T. Now, it may seem that S2 is also starting from this, but don't look at this position. Look at this. This is up, right here, down. So it starts from down and therefore draw it this way. This is A, this is B, the peak. They are in the opposite directions, and therefore what you find a resultant amplitude which is only A minus B. But still you have same frequency, and therefore you're looking at the same color. This is red, this is also red, this is also red, but a dim red, low intensity of red, because we have decreased the overall amplitude. And if these two are of same amplitude, it will become flat. That means there is no electric field left and your place will be completely dark. This is your destructive interference, and you can now look at the reasoning behind different values of delta phi, pi, 3 pi, 5 pi, 7 pi, and so on. If you understand this destructive interference completely, then write down yes in the comment box and then you can leave. Thank you very much.